So hello everyone and welcome to Application Logging with me, Florian. That's me. I'm standing in the woods. We're going to see why this is later. I'm working on the profiler team at Datadog where I'm building a profiler for PHP. I'm an open source contributor. I'm contributing to GraphQLite, to PHP Unit, the PHP core itself. And we heard a lot about open source and how important it is to contribute to open source today, and I just want to add one thing to this. I'm contributing to open source, although I'm married with 5 kids. So that being said, if you don't have 5 kids at home, you can still find time to contribute. So after something different. Imagine a wood. There's a lot of trees, stuff that's in the wood, but no one is actually there. And one of the trees is collapsing and bursting on the ground. And the question you could ask then, did it make a sound? George Berkeley actually never explicitly asked this question, but it matches the core of his philosophy and is used as an illustration of his thoughts. And the main thought he had was esse est percipi, which translates to be is to be perceived. So there's a variety of different perspectives that you can take on this question. And I usually like to take the physical point of view, and that is probably something like if I walk around and see the tree on the ground, I'm like, trees do not grow like this, so it collapsed. We know how sound waves are created in the atmosphere, so it made a noise, definitely. Let's transfer this to our production systems. Who knows what this is? Just shout it. Oh, come on. I'm getting old. This is Gibson, the supercomputer Gibson from the 1995 movie Hackers. So that's the movie you're going to watch on the weekend. Okay, if a system dies in production and no one's around to observe it, did it have an impact? Well, without observability, or no one being around to observe the service going down, we might not know, until a customer complains, obviously. But we all know that most customers, most users, do not really complain. They just go on, find another service that solves their needs, and you don't make the money with them. So application logging as part of observability gives you the eyes and the ears to observe your production systems, to observe the trees while they are collapsing, to know what led to this, to see if other trees are impacted, and to know how to prevent this from happening again in the future. But I hear you say, we have logs. You have probably an Apache, an Nginx, Caddy, you have PHP, FPA, MySQL, Postgres, your cloud load balancer, whatever you have. All these things produce logs for you, a lot of logs. But one of the things that all these things have in common is that all of these are services. And as they are services, they know nothing about the inner workings of your application. You can ask the question even differently with stuff that I have observed in my life. Do these logs, the Apache access log, the Nginx logs, the PHP FPM logs, do these help you with some cases that I have observed? For example, no delivery by a charged credit card, or a customer that receives a newsletter, although they haven't opted in for the newsletter, or products being sold for no money. Believe it or not, I have observed these cases. And in all cases, what will happen is users will call your customer care, your customer service department, and they will check the database. In all cases, you can go and check the database and you find exactly this. You find no delivery, but you find that you have a payment transaction. You find that probably there is an opt-in set, or there is no opt-in set, but you see in the newsletter in the logs. Or you see that in the database, your products have a price of €0. But you don't see when certain things happened, and nor why they happened, and certainly not what led to this. So you don't know about these things happening as long as nobody complains. So so the question is, do the logs like the Apache access log, the slow query log in MySQL, all these logs, do they help with these things? I would say no, they don't. When customers start complaining at the customer service department, your customer service will refund the money, they will reset the opt-in status, they will find out why there's no prices and set prices again for the article. They will probably get yelled at, and they will issue vouchers to make the customers happy again. Now, usually those customer care departments work like this, that when they see something is happening over and over again, what they do is they escalate to the engineering department because they start thinking that this is not a customer problem, this is an engineering problem. And when they do this, it's your job to find out what was going on, why the things are as they are, and how to prevent this happening again in the future. So you have a problem now. You have multiple options, but I want to go to two options that what you can do now when you have this problem that your customer care department escalates to engineering. One is you can just ignore them and live your happy life, whatever will happen in production. Or the other thing is what you can do is you can start doing application logging. Application logging gives you a paper trail for your code. So basically you see what is going on in your application while a certain endpoint is being hit. And in this paper trail, you can start seeing recurring messages. Something like, we are not able to reach a certain third-party endpoint at a specific date of time. Who knows what a postmortem is? Who does postmortems? Okay. Log messages help you doing these postmortems. You can find out what was going on before, what was going on after, if other services were infected as well. I mentioned earlier that I'm working on the profiler team, so if it's on performance, I would not necessarily advise you to use logs for this. But if you don't have anything, it's better than nothing. So what you can do is, for example, if you use curl to send HTTP requests, you can use call get info as a function to retrieve all the timing information about the call request and send this as extra information with your log. And if you have that, you have these performance numbers prominent. You can see like the call get info gives you the DNS result time, it gives you the wait time, the connect time, and all these things. And you can immediately see what was going on. Not only that you did the request, but also why it was slow. For example, DNS took too long for whatever reasons. If you're like me, if you approach a new code base, what I usually do is I start writing tests for stuff that is not yet covered or for stuff that I don't understand, just to understand how to actually use the code. But I've seen other people maxing out the log level and then hitting certain endpoints and seeing what's going on. Also, another thing that I like application logging for in PHP especially is if you see a log message that makes you go, "Ooh, that's interesting," you can set an xdebug breakpoint at that line or a few lines before, and you can debug what's going on there actually. So, in preparation of this talk, I wanted to know what people think what a log actually is, and search the internet. And more often than I like to admit, I got the answer that a log is just text. So let's do this. We have a backup script, backup PHP function that we call, and we echo out succeeded or failed. Just assume the do backup gives back a boolean. And when we run the script and check the log file, then what we get is a failed, probably. Granted, that's something. Whoa, everyone's awake now. But let's have a look at the log file that we know or that we should know, and that gives us more value. So when we look at the PHP FPM log file, this is just a generic example. What we have there is it starts with a date and a time. And this is the date and the time the event happened, like after the event happened. The next thing you see is the notice and the warning, which is the log level. This is basically just, it tells you if you need to wake up at night and do something, or if you can go sleep. And then you see text there. You see the PHP FPM is running. It gives us the process ID. It's ready to handle connections. And then you see there's there can be obviously different pools, and there's different childs that do stuff. And we see that there is childs exited, there's a new child started. We also get information, we also get suggestions from PHP FPM. Like in the middle you see that the pool WW seems busy, you may need to increase some configuration value. And it would be really nice if we could have something like this for our application, for our PHP application. And this is where Monolog comes in. Monolog is logging for PHP. It implements the PSR3 interface, and Monolog is there to send your logs to files, sockets, inboxes, wherever you want to have your logs. And most likely it comes with your favorite framework anyway, and Monolog consists of a few parts that I want to go through. First of all, Monolog has handlers. Handlers are responsible to forward your logs to your desired target. And the desired target can be anything from a file on disk to a service or a database. There is wrappers and so-called special handlers. Special handlers, for example, there is a buffer handler. The buffer handler would buffer all the log messages and not send them out straight, but just buffer them, and then at the end of the request, flush everything in one request. There's also a fingers crossed handler, which is more interesting, that buffers the log messages like the buffer handler does, but it flushes out whenever there is a log message that reaches a certain severity. Next thing is there's formatters in Monolog. A formatter is responsible to format the internal representation of a log to whatever your target system understands. Usually a handler has a default formatter attached, so you might not need to worry about formatters at all in most cases. Then there's processors in Monolog. Processors are there to add extra data to your log message. So there's this dummy processor you can see here. So you have your logger instance, you push a processor, and every log message that you send to this logger, it will call the processor function, and it will add the dummy hello world extra information to your logger. There is some predefined processors that are interesting. For example, the web processor is super interesting because it adds the HTTP request method, the HTTP request URI, and stuff like this to your logs. Next thing in Monolog is log levels. These log levels are defined in the RFC, and they're referenced from PSR3. So you can find a deeper definition. You can find a definition in PSR3 and more documentation on what these log levels mean in the RFC. Just a few examples, because it can be, it's a bit tricky to understand or to get an understanding of what these mean. So if you have a login into your application, that's an info because it's a normal event that is happening in your system. If the login fails, it could be a notice. It's not a warning. Warning is something that's unusual, but people logging in and mistyping their passwords or username is not really unusual, so it could be a notice. Alert in emergency is the thing that wakes you up at night. And critical was super interesting. The definition in PSR3 for critical is a component being down. Now that's interesting because I think that depends a bit on your business logic. If you have, let's say, a review component in your e-commerce store and you get like 2 reviews a month, you could say, well, it being down is critical because a component being down, but it's not like super interesting. But if your payment component is down, it's a component being down, but people cannot spend money with you anymore, so you should get up. I guess the most interesting thing here is that you need to create a shared understanding of what these log levels mean in your team. Okay, how does a log actually look like? This is, technically this is a lie because a log is represented by a log record class that implements the array access. So this is the array you get when you ask for it. So a log record basically is just you have a message, you have the level and the name of the level, the channel that you instantiated your Monolog instance with, a datetime object representing the moment in time that the log function was called, and then you have context and extra. How do you get Monolog in the application? Well, it's pretty easy. You run composer require Monolog. I stated already that your favorite framework, Symfony Laravel, already comes with Monolog. So you have that in your vendor directory, probably anyway, if you use one of those frameworks. Nevertheless, if you start using Monolog in your application, you should make this dependency explicit by running composer require Monolog, so it's explicitly stated in your composer JSON. So we've seen this on a few slides already. It's just Monolog logger, and you give it the channel name, and then you need to push a handler. And the easiest thing is just to put a stream handler on it. The stream handler is usually used to stream, and stream could be a file on disk. And then you give it the severity that it should log. So everything that's lower than this, which debug, for example, would be, it would just discard. If you're using Symfony application, Laravel application, you can just annotate your controllers, and the framework will provide you a pre-instantiated logger class. Okay, how to use that? The log class has functions that are named after the log severity of severity levels. So you have an info, warning, you have alert, critical, all these things. And then you just give it a string, and the string is your log message. And once you check the file, this is what you see in your file then. And this is way more helpful. We have a date and we have a time. We have the channel and the severity, so we already have some information in here, and then we get our log message. In this case, processing payment, and there is an error while processing payment. So when I check this log file, there's a question that I have. Better two questions. First of all, which payment, and second, which payment. So the payment. So when I do this, let's assume I have an order ID and a payment ID somewhere, and I can just string concatenate this together. So I have a processing payment where the payment ID is for some order, and I have an error processing the payment ID for some order. And if I check the log file later, I see it in here. So I see processing payment 54321 for order 12345. Now this is helpful. This is more. And there's two things that we now know more from this log message than from the earlier one. First of all, we know that these two log messages belong together. Before that, it could just be a race condition, and it could just be two completely different payments that have nothing in common. But now we know it's the same payment ID and it's for the same order. So we know these two belong together. We know the payment ID it's for, so we could check in third-party systems the payment ID and search here. And the same is true for the order ID. Now, one thing that's tricky here is still that if we want to search for these numbers, it's a full-text search. There could be false positives. There could be sooner or later payment with the same ID. There could be a user ID with the same ID. We don't know. It could be a false positive sooner or later. And searching for full text is not really nice in there. But what's up with the two brackets that we got here in the back? Let's use them. So one thing I didn't show you, the functions that you have, the info, warning, and the other functions, they have a second argument, and that's an array that you give. And this array is used to give in context information to your log message. So when you change the code to look like this, and you check the log file, what you get is this. So you have a processing payment, an error processing payment, but you get the order ID and the payment ID as a JSON in this case. And what we just did here is called structured logging. Structured logging is the practice of implementing a consistent predetermined message format for an application log that allows you to treat your logs as data and not just as text. And basically, you make your log messages and your context machine readable, and that allows you to easily filter and search the context information. And also, if you have the right tools at hand, it allows you to create nice graphs and alerts on the data easily. So one thing that you see here is you see like there is an PHP exception, the check username failed. And it's not only the log message that you have, the check username failed, but you also get the channel, the context information, you get the date time, you get the extra information. If you add extra information, so what we have here is this is also just metrics created from logs. So technically this shows the timing of a third-party API. So there is a duration context information that we send with the log messages. And then you can make nice graphs out of these. So this shows you the duration of third-party API requests. In this case, two different ones. I was working some moons ago. I was working in an e-commerce retailer, and what we did is we add to this order placed message or order successfully processed message. We added the amount in euros that customer spent and the number of items that customer bought. So we could make a nice dashboard. So we saw that how many money we are making per, I don't know, 10 minutes, 50 minutes, hour, days. And it gives you freedom if you come into the office and you have a dashboard and you see like people are buying stuff, because that means that probably 90% of your shop system is okay if people are still spending money. Another view that you can do that could help is this is just a visualization of how many log messages you have with a specific name. So you have, for example, log messages that has just order placed or user signed up or user signed in. And then you just make a visual representation of how many of these messages you have per whatever 10-minute, 5-minute cycle. And this gives you a view of what is happening in your system. If there is currently a burst of people signing up or logging in. So sometimes if you do these kind of visualization, you see that your marketing department did something without telling you afterwards. So what should we log now that we know all the thing? What is the thing that you should log? Well, basically, when a user logs in or a user logs out, I would even advise to log the, let's say, implicit logout of the session being removed from your session store. When user changed their data, we had this relatively often. I don't know why, that customers complain in customer care that their data is not correct anymore. And it turned out that they changed the data on their own for whatever reason, but it failed. Also, what we had at the time is our customer care people could impersonate the customer once they authenticated them and could change the data. And then it's a good idea to also store the information that the customer data was changed by a customer service member on behalf of the user. Orders, payments, refunds. Yes, every time money changes the owner, you should log this, the amount of money, the reason why. Because there is this German saying, probably it's a saying in other languages as well, but it goes something like, money is when the friendship ends. So people are not happy when they lose money. Exceptions and errors. For exceptions and errors and fatals, Monolog has a nice error handler class that you can instantiate. And basically the only thing you got to do is you instantiate it into the constructor, you give you a pre-configured Monolog instance. And then this error handler will register an exception, error, and fatal handler for PHP, and will then write those log messages to the logger you gave it. There is things that you should not log. Please don't. Usernames and passwords. I've seen this to debug the authentication. And then you find access tokens in log files that are not guarded by anything. I've also seen serialized objects. I have this, the thing was like we had a doctrine object of an order, and you can just serialize that and attach that to a log message. Nobody will read that. The other thing is numeric error codes. I know there's people like numeric error codes because it's small, but then you got to have a document around that describes what's going on. And the usual thing is you always need to remember that you are logging not for the sake of logging, but you're logging for the future you or for the future SRE person that gets awake at night from a pager and sees a number on their screen and has no idea what's going on. Okay, regarding performance, who has heard something like this? I have a good idea, let's forward the message to Slack. First of all, no one reads that Slack channel. The other thing is, let's do some math. Let's assume we send messages to Slack. They have an API. Like there is a Slack handler actually, Monolog. It's super easy to send your messages there. And let's assume they have 100 milliseconds of API round trip. If you send 20 log messages there for your HTTP request, that adds another 2 seconds of wall time just for sending logs there. Now you could say, well, there's the buffer handler. The buffer handler would help, definitely. We could just buffer everything up and at the end of the request, send it out in one bulk request. This comes at a price. And the price is if your script dies before the buffer handler could flush the log files, you will lose all the log files. So usually what's a good advice, or what I usually tend to do, is send the log files to something that's near in a network and latency point of view. So it could be just a file on disk, RAM drive, or maybe RabbitMQ, MQP, something. And then have another tool pick up the log message. There's a lot of tools out there. There's also vector.dev that can just pick up log messages from any file or from any sync and deliver to whatever logging tool you have. And always measure the performance impact that you add with logging. I had the Slack example, but I've seen profiles where 50% of wall time was spent writing logs to somewhere because people wrote logs to a NFS-mounted file on another server. So always measure your performance overhead. So to quickly recap, add structured logging to your system. Keep a document around for the shared understanding in your team about the log levels and who should wake up at night. Send those logs to a log management tool that helps you automate a lot of things and find patterns in the data that you send there. and observe the trees while they're collapsing. Happy logging. Are there any questions?
Should logging have stack traces?
So I'm working on a profiler, and collecting the stack trace is the most expensive things that we have to do. So if you can avoid collecting a stack trace, if you're logging an exception, there is already a stack trace. So PHP has already done the work for you, and you paid the penalty anyway. So you could attach the stack trace. Otherwise, I think it's more important that the log message is unique enough so that just by the name of the log message you can find out where it originated from. Oh.
Okay, thank you.
Okay, right. Thank you for your speech. The question is, let's say we have a microservice architecture, and we have PHP, Go, and Node.js running in for a simple reason, for a single reason. So all of them, they have different log standards, different even maybe codes for errors. How do we manage them?
So let me go back. Yes. So this will work for PHP. So you have monologue, you write this thing down, and then you have like vector.def, and you need to configure vector and tell it what is what. Like the most stuff it will magically understand, but you have to configure it and tell it what is what. So vector, one of those tools, sees this here as a source where it gets information from, and then it has things where it streams stuff to. So you need to tell it that your extra information or your structured information is the stuff right here. Basically, vector, for example, will make out of this one JSON, you could say though, with the datetime, the channel, the severity, the message, your order ID, payment, and stuff like this, and like extra information that you have in the end there. And then you could use the same tool to pick up a log message from another tool in another format. You just need to like, for most of the things, like for this log message line that you see here, there is a predefined reader that understands what's going on here. So I don't know for Go, but Go, Ruby, Python, other languages, they have other standards, other tools, other like log lines that they produce. There's probably standards as well that you can use and then ingest those things. And then send them to your tool. If you're talking microservice and say in sense of you have one service that sends data or HTTP request to another service and then waits for a response and does something. What's super helpful if you add, say, some request ID or trace ID or something. And if you add this trace or request ID to your logs in your service and you send this with the HTTP request to the other service, and that service also adds the same trace ID to his own logs, if you send it to the same logging backend, you can correlate the information there.
Thank you.
I think that's all we've time for, so thank you.